Okay, so in your Chemistry 1 course, you might run along something called the law of constant composition. It's also called the law of definite proportions. These two are the same thing, they're just two different names for it. So let's jump right into it with an example. Say we have iron chloride. Okay, so we have FeCl3, and that's iron chloride. So FeCl3, iron chloride, is going to be iron plus chlorine. And so here's your 3 moles of chlorine. So we have 1 mole of iron and 3 moles of chlorine. So that's going to, if you put those together, that's going to make iron chloride. So in this formula, we have 1 mole of iron and 3 moles of chlorine. But what we're dealing with is we're dealing with the amount of iron in grams and the amount of chlorine in grams. So however many grams of iron you have plus however many grams of chlorine you have is going to equal the total number of grams of iron chloride that you have. So that might seem really obvious. You know, if you have iron chloride, which is iron and chlorine, then of course, however many grams of iron plus however many grams of chlorine you have is going to be the total number of grams of iron chloride. So let's look at how we can apply this information and look further into the law of constant composition because it gets more interesting than that. Now here is a chart, and this may look familiar, it may look like something on your homework. Here's a chart, and this is dealing with, again, iron chloride, which is Fe, the iron, plus Cl3, 3 moles of chlorine. And as you can see here, the total mass of FeCl3 equals the mass in grams of Fe plus the mass in grams of chlorine. So if you look at this top row in the chart for sample A, we have the total mass of iron chloride is 3.785 grams. Now that's going to be equal to the total mass of iron, which is 1.302 grams, plus the total mass of chlorine, which is 2.483 grams. So if you add those two together, you're going to get this 3.785 grams over here. But then in this table, you have sample B, and we don't have the total mass in grams filled out. We need to fill that in. And we don't have the mass of iron. All we have is the mass in grams of chlorine, 2.929 grams in this sample B. Now there are 3 ways to complete this chart. The first way we can do it is we can take, look all the way over here to the right of the table, and we can take sample B's chlorine amount, the 2.929, and we can divide that by sample A's mass of chlorine in grams, the 2.483. So if we take 2.929 grams divided by 2.483 grams, we're going to get 1.18. So if you take sample B's chlorine, 2.929, divide it by sample A's chlorine, 2.483, you get a factor of 1.18. So if the mass in sample B divided by 1.18 equals the mass in sample A, for chlorine, then we can do that same thing for iron. Whatever the mass in sample B of iron is, if you divide that by 1.18, you're going to get 1.302 grams. So if you have question mark divided by 1.18 equals 1.302 grams, then all you have to do is take this 1.18 and 1.302, multiply them by each other, and you're going to get what your question mark is. So 1.18 times 1.302 equals 1.536 grams of iron. So the answer here for sample B's mass of grams of iron is going to be 1.536 grams. So if you have that 1.536 grams and you divide that by 1.18, you're going to get the mass in grams that already came with the table for sample A, the 1.302 grams. And that's our first way to solve this, which is written down right here. If you take sample B of chlorine in grams and divide it by sample A of chlorine in grams, that is going to equal the same amount as if you were to take sample B's amount of iron in grams and divide that by sample A's iron in grams. They're going to equal each other. So before we get into all these calculations, I just wanted to do a little math refresher so we don't go too fast with the math and confuse you. So let's take, for instance, just the simple problem of 4 times 3 equals 12. Okay? Now, if we take 12 and we divide it by 4, and we need to know what that question mark is. Well, 12 divided by 4 equals 3, doesn't it? Well, what if we take the opposite? What if we swap these around, this 4 and this 3? What if we have 12 divided by 3 equals question mark? Well, isn't 12 divided by 3 4? So see, that proves that you can swap these two numbers across the equal sign from each other, and you're going to get the same answer. You can swap the bottom of the division bar with the number on the other side of the equals. Now you can't swap the top number on the division. You can only swap the bottom number on the division, under the division bar, and the number on the other side of the equals. So 12 divided by x equals y, 12 divided by y equals x. They're interchangeable. And that also means that if you take the bottom number of the division bar and the number on the other side of the equals, if you multiply those two together, you're going to end up getting whatever number is on the top of the division bar. So if you have 12 divided by 4 equals 3, you can take that 4 times that 3, and you're going to end up getting 12. If you have 12 divided by 3 equals 4, well, same thing. 3 times 4 equals 12. So see, these numbers are all interrelated with each other and can be kind of swapped around and played around with to get whatever answer you need. So if you have 12 divided by question mark equals 4, well, you can swap this question mark and this 4 around and turn it into 12 divided by 4 equals question mark. And we know 12 divided by 4 is 3, so question mark equals 3. Or if you have 12 divided by question mark equals 3, well, you can swap these around and you end up getting 12 divided by 3 equals question mark. And then we can solve it because we know 12 divided by 3 equals 4. Now if you have question mark divided by 4 equals 3, you can't swap the top number on the division symbol and the number on the other side of the equals. That doesn't work. But what you can do is you can take the bottom number of the division bar and the number on the other side of the equals and just multiply them by each other, and that's going to give you the top number, your question mark you need to find. So 4 times 3 equals 12. So 12 is that question mark, that top number on the division bar. So if you have question mark divided by 3 equals 4, you're just going to take the 3 times the 4, and that's going to give you 12, which is what the question mark is. So let's take one more example. Let's take 15 divided by question mark equals 3. Well, we know we can swap the bottom number of the division and swap that for the number on the other side of the equal sign. So we can change this into 15 divided by 3 equals question mark. So 15 divided by 3 equals 5. So question mark is going to equal 5. Or if we have 15 divided by question mark equals 5, well, we can swap this question mark for the number on the other side of the equals sign. So we can get 15 divided by 5 equals question mark instead, which is an easier way to look at it. So 15 divided by 5 equals 3. So in this case, question mark equals 3. Or if we have question mark divided by 3 equals 5, well, then we can take the bottom number from the division times the answer on the other side of the equal sign. We can take 3 times 5, and that's going to give us your question mark. So 3 times 5 is 15. So in this one, the question mark equals 15. Now you may ask, but how do I know that I'm supposed to take the grams from sample B in chlorine and divide that by sample A's chlorine grams? What if I accidentally flip them and divide them the other way? What if I take the sample A's mass in grams of chlorine and divide that by sample B's mass of chlorine? What if I flip it? Well, that's okay too. We can do way number 2 to solve this chart, and we can take sample A's mass of chlorine, 2.483 grams, and divide that by sample B's mass of chlorine, 2.929 grams, and that gives us 0.8477 grams. So if that gives us 0.8477 grams, all we have to do is remember whichever way we divided these numbers, that's the same way we need to divide the numbers in the iron column on the table. So in this case, we took the mass of sample A of chlorine divided by the mass of sample B of chlorine, and we got 0.8477. So that means if we take the mass of sample A for iron and divide it by this question mark, the mass of sample B for iron, that should give us the same number, 0.8477 grams. So if we take 1.302 divided by question mark, the mass of sample B of iron, that is going to give us 0.8477 grams. All we have to do is we can swap these out, the question mark for the answer, and we can take 1.302 divided by 0.8477 gives us question mark, which is 1.536. So the answer to what is sample B's amount of iron in grams, that's going to be 1.536 grams, which is this second way to complete the chart, which is if you take sample A of chlorine in grams and you divide it by sample B of chlorine in grams, that's going to equal the same amount as when we take sample A of iron in grams and divide that by sample B iron in grams. So both of these ways show us that we're just dividing what we know, which we know this chlorine column because we have the information for both sample A and sample B for chlorine. So you can divide these either way. You can divide sample A by sample B, or you can divide sample B by sample A. It doesn't matter. Just whatever you get as an answer, you're going to divide the iron column in the same way. So if you divide, when you're doing chlorine, if you divide sample A by sample B, make sure that you're dividing sample A's iron by sample B's iron. If you divide sample B's chlorine by sample A's chlorine, then make sure you do it the same way with iron. Divide sample B by sample A. Just make sure you do it the same way on both columns, and you're fine. So you don't have to remember one way to divide or the other. You can do it either way. It doesn't matter. Now, the third way to solve this table deals with the mass ratio, and this is really what the law of constant composition is all about. So we have this table here, and we know all of the stuff that's in sample A. So we know the mass of iron in sample A, and we know the mass of chlorine in sample A. So instead of dividing up and down, dividing the chlorines into each other, we're going to divide the mass of iron that we know from sample A, and we're going to divide that by the mass of chlorine that we know from sample A. So the mass of iron from sample A and the mass of chlorine from sample A. So that's 1.302 grams divided by 2.483 grams, which gives us a mass ratio, they call it a mass ratio, of 0.524. So that is what is called our mass ratio. When we take the amounts from the same sample, the amounts of iron divided by the amount of chlorine. That gives us our mass ratio of 0.524. So if the mass of iron in sample A divided by the mass of chlorine in sample A gives us 0.524, then shouldn't the mass of iron in sample B, if we divide that by the mass of chlorine in sample B, shouldn't that also give us 0.524? Yes, it should. So if we have question mark, which is the mass of the iron in sample B, divided by the mass of chlorine in sample B, 2.929, is equal to 0.524, then all we have to do to solve this question mark is to multiply these two numbers together, 2.929 times 0.524. So 2.929 times 0.524 is going to equal 1.535 grams of iron. And that is the third way, and really the whole definition of the law of constant composition is there's a mass ratio between the amount of grams of one element and the amount of grams in the other element. If you just divide those into each other, you get a mass ratio, and you can use that to calculate the amount of grams in a different sample. So what about filling in the first column of the chart, the total mass of iron chloride in grams? See, we have this question mark here we haven't addressed yet. Well, let's go back and start from scratch, and we're going to use this mass ratio method to solve this table, because this method is the most accurate, and this really demonstrates the law of constant composition, which is what we're talking about for your chemistry subject. So we're going to take the sample A of iron, which is 1.302 grams, and we're going to divide that by sample A of chlorine, which is 2.483 grams. So 1.302 grams divided by 2.483 grams, and that's going to give us 0.524 as a mass ratio. So we're going to take that mass ratio, and if we divided the sample A of iron divided by sample A of chlorine and got that mass ratio, then that mass ratio should equal sample B's iron, which is question mark, it's right here, divided by sample B's mass in grams of chlorine, which is right here. So if we take this question mark divided by 2.929, that should also give us the same mass ratio that we got when we divided the sample A's stuff, sample A's mass of iron divided by sample A's mass of chlorine. So if we have question mark divided by 2.929 grams equals the mass ratio of 0.524, well then remember our math refresher. In order to solve this question mark, we can just take this bottom number of the division bar and multiply that by the number on the other side of the equal sign. So 2.929 grams times 0.524, and that's going to give us 1.535 grams. It's actually It's actually 1.534796 grams, but it's rounded to 1.535 grams. So that answer, 1.535 grams, goes to answer our question for the mass of iron. So if we have 1.535 grams in the mass of iron, and we have 2.929 grams of the mass of chlorine in sample B, if you just add those together, that's going to give you the total mass of iron chloride. So 1.535 plus 2.929 is going to equal 4.464 grams total of iron chloride. So see, you just have to add these together. It's just an addition problem to get the total mass. Okay, so let's take another example. Let's take carbon dioxide, which is CO2, which means that if you take 1 mole of carbon and 1 mole of O2, then you're going to get CO2. So CO2 is carbon plus O2. So let's take a look at carbon on the periodic table, which is right here. And if you look at the bottom number here, this 12.01, that's carbon's atomic weight. So if we take 12.01 grams of carbon, that's going to equal 1 mole of carbon. And now let's look at oxygen, which is 2 blocks over. That's atomic weight is 16.00. So, but we don't have one atom of oxygen here. We have O2. So you take that 16 times 2, which is 32. So we're going to have 32.00 grams of oxygen. And this is carbon. So if you have 12.01 grams of carbon, which is the 1 mole of carbon, and the 32.00 grams of oxygen, which is the O2 up here, if you add all of those grams together, you're going to get 44.01 grams total of CO2. So 1 mole of CO2 is going to equal a total of 44.01 grams of a combination of carbon and oxygen. So this is the total grams. Now if you take the grams of carbon, which is 12.01 grams of carbon, and you divide that by the 32.00 grams of oxygen that's in the formula, that's going to give us our mass ratio. So for every 12.01 grams of carbon in carbon dioxide, we're going to have 32 grams of oxygen in carbon dioxide. So if you divide those numbers, you get 0.375 as a mass ratio. And so that means however many grams of carbon you have divided by the number of grams of oxygen that you have in CO2, if you divide those numbers, you're going to get this same mass ratio of 0.375. And that exactly is what the law of constant composition is all about. The ratios of grams of these elements always stay the same in the formula. So for CO2, the mass ratio is always going to be 0.375 when you divide the grams of carbon by the grams of oxygen. So if we had, for instance, say we didn't have 12.01 grams of carbon, say we had 6 grams of carbon, and we need to know how many grams of oxygen we have in CO2. Well, we know that if we divide that 6 grams of carbon by however many grams of oxygen, we will get that same mass ratio of 0.375. And we know from our math refresher that if we want to solve this question mark under the division bar, we can just swap that out for the answer on the other side of the equal sign. So instead, we get 6 grams of carbon divided by 0.375, and that is going to give us our grams of oxygen. So 6 grams of carbon divided by 0.375 is going to give us 16 grams of oxygen total. And so if we know we have in carbon dioxide 1C plus O2 equals CO2, then the grams, 6 grams of C plus 16 grams of oxygen gives us 22 grams of CO2. Or what if we had 20 grams of oxygen, and we need to know how many grams of carbon we have in CO2. Well, we know the mass ratio, 0.375, is equal to the grams in carbon divided by the grams in oxygen. So we know we have 20 grams of oxygen. So question mark grams of carbon, because we don't know how many grams of carbon we have yet, divided by what we do know, which is the 20 grams of oxygen we have, is going to equal that same mass ratio, 0.375. Now, since we don't know the number on the top of the division bar, we can take this bottom number, the 20 grams of O, and we can multiply that by the answer, the mass ratio, 0.375. So 20 times 0.375 is going to give us what our question mark is, the number on the top of the divisor bar. So 20 times 0.375 is 7.5. So 7.5 grams of carbon if we have 20 grams of oxygen for CO2. And so if we have 7.5 grams of carbon and we have 20 grams of oxygen, then if you add those together, we will have a total of 27.5 grams of CO2 altogether. So now let's try this solving these problems using this table like you might see in your homework. So as you can see, we have sample A is already filled out for us. The total mass of sodium chloride, NaCl, in sample A is 99.95 grams. And that means since this is the total mass of sodium chloride, and sodium chloride is made up of sodium plus chlorine, then that means this 99.95 grams is equal to the mass of sodium in grams plus the mass of chlorine in grams. And that's this 28.30 grams plus 71.65 grams. So that first line is already done for us. Now, in order to figure out the rest of this table, we're going to take what we know from that first line, that first row, and we're going to find the mass ratio. So we're going to take the grams of sodium and we're going to divide that by the grams of chlorine, and that's going to give us our mass ratio. So the grams of sodium in this case is 28.30 grams sodium divided by that 71.65 grams of chlorine, and 28.30 divided by 71.65 is going to give us 0.395, and that's our mass ratio. So now we can take this mass ratio and use it to solve the other two rows for sample B and sample C. So let's look at sample B first. We don't know what the total mass of sodium chloride is, but we do know what the mass of sodium is in grams, and we do not know what the mass of chlorine is in grams in this one. Well, we have our mass of sodium in grams, 35.75, and we have our mass ratio, which we found out from the previous sample, sample A, that's 0.395. So if we take the grams in chlorine, this question mark, grams of chlorine, and we multiply it by the mass ratio, 0.395, we're going to get the mass of sodium in grams as the answer. So in order to figure out what this question mark is, we can take this 35.75 grams of sodium and divide that by the mass ratio, 0.395. So 35.75 grams of sodium divided by 0.395 mass ratio, that's going to equal 90.51 grams of chlorine. So that's going to fill in our question mark over here, 90.51. 90.51 grams of chlorine. And just like on the top row for sample A, the mass in grams of sodium plus the mass in grams of chlorine is going to equal the total mass in grams of sodium chloride. So 35.75 plus 90.51 is going to give us 126.26 total grams of sodium chloride. Now let's do the same thing for sample C. For sample C, we don't know what the total mass of sodium chloride is, and we don't know what the mass of sodium is, but we do know the mass of chlorine in grams is 50.00 grams. So if we take the mass of chlorine times the mass ratio, that is going to give us the mass in grams of sodium, which is what this is. So the mass of chlorine in grams is 50.00. So we take that times the mass ratio, and 50 times 0.395 is 19.75 grams of sodium. So that's going to tell us how many grams of sodium we have. 19.75. And if we take this 19.75 grams of sodium plus the 50.00 grams of chlorine, and we add them together, that is going to give us our total mass for sodium chloride, which is 69.75 grams. So I hope that gave you enough practice and that made sense for you. If you have any questions at all or any comments, please leave them in the YouTube comments under this video, and don't forget to like and subscribe.